Now let's talk about the binomial distribution. The binomial distribution is the case when I always have only two outcomes. I call these outcomes either success or fail. The success, I refer to it by the letter P, and the fail by Q. What does this mean? If I have a problem where I have either I'm picking white balls or black balls, so I have probability of having a white ball or a black ball and no other options. That's why I call it binomial. I only have two possible outcomes, either white or black. Now, if I'm picking up white balls or black balls, I need to know how many balls I am picking up. So, the next thing I have to know is the number of trials. The number of trials, I refer to it by the letter N. After that, let's say I'm picking 8 balls. Out of these 8 balls, I want to have 3 balls. The 3 balls, I consider them the number of successes. Number of successes to be the letter R. So the normal distribution outcome would be in this formula, N combination R times the probability of success to the power of R times the probability of fail to the power of N minus R. You don't have to panic because this is the probability. The value of the probability. You don't have to panic because we can use our graphical display calculator and it makes the whole process easier for us. These successes and Q, since they are probabilities, these are probabilities. Since the success is P, then the fail, Q, must be equal to what? Because the total probabilities add up to 1, so the probability of fail is simply equal to 1 minus P. Another thing I have to know about the binomial distribution is the expected value and the variance. The expected value for the binomial distribution is simply equal to N, which is the number of trials, times P, which is the probability of success. The variance for a binomial distribution is simply equal to N, which is the number of trials, times P, which is the probability of success, times Q, which is the probability of failure. So I have it to be N times P times Q, which I know it as 1 minus P. This is all what we need to know about the binomial distribution. Now we'll have an example and we will be using our graphical display calculator in order to solve our example. In our example, we have a fair dice which is rolled 6 times. So the first thing I know about This given that the number of trials, which is n, is equal to what? 6. We need to find the probability that, let's start for part A. 1/6 is rolled. Part A, I have 1/6 is rolled. So I have the number of trials is 6. Number of successes I want 1/6, so R is equal to 1. Also, I need to figure out the probability of success. My probability of success in this case, the probability of success, since I want a 6 to be rolled, since it's a 6, then the probability to have a dice of having an outcome of 6 is simply, it's one face out of 6 faces. So now I have the number of trials, I have the number of successes that I want, and I have the probability of success. Now I can use my graphical display calculator to find the probability that 1/6 is rolled out of 6 times. So I go to my graphical display calculator, I go to menu, I go to statistics, exit, and I go to distribution, which is dest. I go to binomial, and I go to binomial probability distribution because I want only 1/6 to be rolled. I go to BPD, which is F1. Now I have the data to be variable. The X, I want it to be 1 because R is equal to 1. The number of trials would be 6. And the probability of success is 1/6. And then I go to execute. Execute again. I have the probability that only 1/6 is rolled out of the 6 times would be 0.402. So the probability of having 1/6 of having 1/6 to be rolled is simply equal to 0.402. 0.402. This is for part A. Now, for part B, what's the probability no 6s are rolled? No 6s are rolled, it means any other number other than 6. So, any other number other than 6, I have the probability of any number, probability of 6 prime, which is not having 6, equals 1 minus 1/6. So, probability of not having 6 is equal to 5/6. And I want not 6 times. So, the probability of no 6s simply equal 5/6, and I want it 6 times, so I make it to the power of 6. And this is equal to, I go to my run matrix, I have 5/6, all of it to the power of 6. And this is equal to 0.335. Let's go now to part C of the question. We want at least 3 6s to be rolled. At least 3 6s, it means either 3 6s are rolled, either 3 6s or 4 6s or 5 6s or 6 sixes. So I want the probability of X to be greater than or equal to 3. In this case, I use my graphical display calculator. I go to menu statistics and I go to distribution, binomial, and I use BCD, the cumulative distribution function. I press F2. I have the lower number of successes that I want is 3, and the upper number of successes I want either 3, 4, 5, or 6 sixes, right? So I add it as 6, and the number of trials I have at 6, and the probability of success is 1/6. It's already given there. So I just execute. I have the probability to be 0.0623. So 0.0623. I hope it's clear. We didn't need to use the formula. It's very important for you to know exactly how to use your graphical display calculator well, because most of this topic depends on your skills on your graphical display calculator.